Hi everybody, Professor Gassimi here. This week we'll be discussing speech. Now, at the end of the last lecture, we concluded the conversation about constituencies, parsing, and dependency. And the reason why we discussed this, let me say, structural approach to natural language processing last time is because it's complementary to the purely statistical approaches that we had taken up until that point. Language is not just a sequence of one-hot vectors. There are structures that exist within language, and it stands to reason that we can take advantage of those structures to do a better job classifying, translating, generating text, what have you. Now, this week, in that same spirit of kind of moving a little bit beyond just the statistical approaches, we're going to be thinking about speech, which is the object that these text strings we've been dealing with is actually trying to represent, right? Before we as a species wrote things down, we communicated with each other orally, and languages sort of were created in their written form to capture those spoken communications. Now, of course, when you want to analyze speech, there are great advantages. One of the advantages is that it's a much richer source of data. But of course, there are additional challenges that come with analyzing audio waveforms. We'll be speaking a little bit about that more in the context of the modules this week, and we'll get just a little bit of exposure to it in the speech analysis homework. My hope is that it won't be too intense, but maybe we'll whet your appetite for future speech processing work that you can do in your own time after the semester or as part of your project. Okay, so you all know this already. For most of the course, we've been thinking about language in a statistical way, and in fact, a purely statistical way. We've taken sentences like, the quick brown fox jumped, and we came up with a set of usually one-hot vectors to represent them, and then we did some interesting transformations of these one-hot vectors, either with word-to-vec or some embedding plus an encoder-decoder network or a transformer so that we could do some cool stuff with these one-hot vectors, right? But remember that at its essence, effectively, what you're doing is, in these approaches, is you're finding ways to either represent or re-represent and combine these one-hot vectors to do neat things with text. Now, as of the last lecture, we had discussed how we're going to extend that purely statistical approach to text to consider also the structure of the language. So we wanted to consider the fact that, for example, the is a determinant and quick is an adjective and fox is a noun. And we might want to know that in addition to maybe some of the higher order structures or constituencies that emerge as a function of that. We might want to account for that and use it to inform our analysis. And realistically, and practically, that's what people do. They take the structural and statistical properties of language and use them together to accomplish what neither of those two can accomplish as effectively alone. But even with access to the grammar and the words and nice representations of both with a transformer or beautiful parts of speech tagger, you still actually don't have the whole context here, right? You're missing information on how things were said. Even though you have access to what was said, that information on how something was said could be as important, or some might even argue more important than, depending on the circumstances, knowing what was said. And I think a very easy way to illustrate this that doesn't use speech but uses something visual is the set of the three memes that I've shown here on the right. Obviously, the three forms of congratulations are interpreted vastly differently depending on the accompanying context. In this case, it's an image context. But very similarly, speech can communicate and often does communicate the intentions in ways that the text alone cannot. And so in this lecture, we're going to be discussing speech, how it's generated, and what kinds of qualities you can extract that might further augment our natural language data. The thing I want to remind you about as we go through this together is that speech, in addition to being a a source of the text data that you've become used to dealing with, a way to sort of generate that from an audio waveform, is really much more than that. It has contained within it these important kinds of context that take you just beyond the words on the page.